Good evening. Well, as you've all heard by now, there's been another unsuccessful American moonshot. This time the idea wasn't to land the vehicle actually on the surface of the moon, but to put a rocket in a closed path round the moon so that it could send us back useful information. Well, unfortunately it failed because there was some kind of a structural fault and the rocket fell back into our atmosphere and was burned away in the manner of a shooting star. Well, that's a great pity because a rocket round the moon would be a really useful thing. It would send us back a great deal of information that we can't get in any other way. But I'm sure that an experiment of that kind will be made again in the near future, and I think we've every hope of success. At the present moment, the moon is about half. And if you look at it through any small telescope, you'll be able to see not only the dark patches, which we miscall seas, but also these craters, these circular walled formations, which seem to cover most of the moon. Well, you can see the dark seas even without a telescope at all, because after all, the moon is by very much our nearest neighbor in space, our nearest natural neighbor, that's to say. Its distance is less than 250,000 miles. Now, let's imagine some kind of vehicle going round the Earth. By the time it's gone round 10 times, it will have covered a total distance which is greater than the distance between the Earth and the moon. And remember that Venus, the closest of the planets, is always at least 100 times as far away as that. Well, rockets, as we know, have been sent to the moon. In September 1939, the Russians landed their Lunik 2 on the moon's surface, not far away from the great 50-mile crater which we call Archimedes. And then in October 1959, just a bit less than a year ago, came that great triumph with the Russian rocket Lunik 3, which actually went round the moon and photographed that part of the moon's surface which we can never see from the Earth because it's always turned away from us. Well, I, for one, certainly won't forget those pictures, because they came through on the night we were going to do one of these Sky at Night programs, and we were the first to give these pictures in this country. And that actually was a picture taken in the studio in October 1959, when I was reading out the announcement. Well, these pictures of the other side of the moon were quite staggering. They were much better than we dared to hope, and this is the first one that came through. In fact, part of that picture shows areas of the moon that we knew. On the left-hand side, there are regions of the moon which are turned towards the Earth and which we can therefore study. But all that part of the moon on the right-hand side of the picture was completely unknown before Lunik 3 made its flight. Now, there are one or two very interesting points about that picture. First of all, there are fewer dark areas than there are on the side we know. There's just one, the Russians call it the Sea of Moscow, which is about 190 miles across. But a lot of the picture appears blank. All this area appears as if it's completely featureless. And from that, a lot of people have concluded that these newly examined regions of the moon are smoother than the regions we've always known. Now, personally, I don't think that's so, and I'd like to explain just why I think that. So let's have a look now at an ordinary full moon picture. This one actually was taken at the Paris Observatory, and it shows the dark seas pretty well. Now, I'm going to put this picture deliberately out of focus. I'm going to blur it. Now you can see that the picture is no longer clear. The Russian Lunik 3 pictures of the other side of the moon were quite obviously not so sharp and clear-cut as ordinary moon pictures. They were wonderful under the circumstances, but of course they were defective in definition. And I think the resolution was just about the same as on that blurred moon picture that you can see now. Well, as you'll see, the craters just don't show up at all. It's only the dark areas that do. Now, look at that area on the moon which we call the fourth quadrant on the upper left-hand side of your picture. On this out-of-focus moon photograph, it looks blank. But now, let's have a look at it as it's seen under a different lighting and on a larger scale. And you can see that it's absolutely pitted with craters. There are thousands upon thousands of them. And there, I think, we've got the answer. The newly examined regions of the moon are, I'm sure, just as crater-scarred and rough as the old ones. Only on these first Russian pictures, the craters naturally don't come out. You can't expect them to. Also, I think that this has a shows how important shadows are when we examine lunar craters. You see, a lunar crater is only really well seen when it's near what we call the terminator, or the boundary between the light and the dark sides of the moon. Let's have a look at one of the most famous craters on the lunar surface, Ptolemaeus. It's near the center of the moon's disk, and when it's near the shadow line, it's extremely conspicuous because it has shadow inside it. But now let's look at Ptolemaeus near full moon, when the sun's high over it and there are no shadows. Even though the crater's 100 miles across, you simply can't see it. It's there. And even with a good telescope, and when you know exactly where it is, it's very hard to make out exactly the position of Ptolemaeus when there's no shadow inside it. Now, this is important, too, because it helps us to measure the depths of the lunar craters. A lot of people have asked me about that, and to try and explain how it's done, I've made a model of a typical lunar crater, and I'm going to show you the progress of sunrise over it. I'm going to illuminate it from the side by means of a lamp, and I think for this we'd better have the studio lights out. Now, first of all, when the sun first appears over the crater, it illuminates only one wall. Then you can see the complete circle. And as the sun slowly rises, you get the central peak, the shadows inside draw back, until finally, when the sun is high over the crater, there's no shadow left inside it at all. Now, that process, as I did it then, takes only a few seconds. Of course, on the moon, really, it takes some time, because the moon spins very slowly. But I'm going to put the lamp back now to a mean position, so we get some shadow inside the crater. Now, we can measure the length of that shadow, as seen from the Earth, obviously. We can also work out the height of the sun above the wall. And from that, we can get the height of the wall above the bottom of the crater. In other words, the depth. And I've got a diagram here which shows you the theory of it. There's the sun shining over the crater and filling it with shadow. As the sun rises, the shadow shrinks. Then, as the shadow shrinks, in this position, we can measure the length of the shadow. Now, we also know the height of the sun above the crater, and we can therefore construct what is, in effect, a right-angled triangle, of which we know two sides and one angle. And so we can work out the entire triangle, and from that, we can tell how deep the crater is. In fact, some of these lunar craters turn out to be very deep indeed, and the deepest of the lot is called Newton, and that has walls which are 30,000 feet above the bottom of the floor. So if you put Mount Everest inside it, not even the top would poke out. On the other hand, these craters are not really very deep in comparison with their diameters. They're much more like shallow saucers than deep wells. Now, we don't quite know how these craters were formed. Personally, I think that the large ones are probably volcanic, although some people think that they're due to meteorites hitting the surface. Well, that remains to be cleared up. Also, we don't know how much dust or ash there is on the moon. According to one rather gloomy theory, the moon may be covered with deep drifts of ash, so that it's said that space travelers of the future will simply sink into it with all their gear. But on a new Russian theory by Barabashev, it's suggested that the moon may be covered with a layer of crushed material, crushed rock, with grains from 3 to 10 millimeters in diameter. Well, we don't know for certain as yet, but I'm going now to call in Dr. Gilbert Fielder, who's the director of the lunar section of the British Astronomical Association, and I'm going to ask him to tell us what he thinks about dust on the moon.
Well, I suppose we can't be absolutely certain that there's dust present on the moon, but I should be certainly very surprised if none at all were found. Mare Imbrium is one of the gently undulating areas of the moon's surface, and there is at present a controversy raging as to whether this consists of solidified lava or dust. Now, if we look at a large crater, this particular crater here has a diameter of about 140 miles, and it has a depth of about 3 miles. This might have been produced by a very high-energy meteorite which collided with the moon and exploded at some remote time in the past. Now, similar collisions might have occurred on the Earth's surface, of course, but any such scars hit on the Earth's surface would have been eroded away by the action principally of wind and water. So we don't see them today. Now, it's been estimated that on the moon there are very many meteorites hitting it. And the Earth's atmosphere has been estimated to receive tens of thousands of tons of meteorites every day. And we know that, of course, the same certain proportion of these meteorites must be hitting the moon also. So the net result of all this must be that the moon's surface becomes broken up, pulverized by this action, and of course, for this particular reason, one would certainly expect to find some dust present on the moon. Now, if we look back at this picture again to the smaller craters, we see that these were formed after the larger crater, and going to still smaller ones, we come to many more, and many of these must have hit the moon to produce a certain amount of dust. So it seems reasonable that there must be some dust on the moon. Now, if we also know that the surface of the moon is a very, very poor conductor of heat. The sun's heat reaches the moon, of course, and some of it is reflected from the surface as heat waves, and some penetrates the surface and is re-emitted as radio waves. Now, we can measure the heat waves with sensitive heat-detecting instruments used in conjunction with large optical telescopes, and we can measure the radio waves with the aid of radio telescopes. And if we make these measurements, we can interpret the results in terms of a model, assuming that the surface is built up of a layer of solid rock, which has a covering of a certain thickness of granular rock. And of course, this granular rock might well be in the form of a dusty medium. But it would be wrong to assume that all the moon was like this particular model. This is a very average sort of result, because the measurements which are made do not refer to a particular spot on the moon's surface. They're made over a large area and cover a large area of the surface, such as we have indicated in this picture. In this case, the area measured would be one of the flatter areas on the moon. Whether it's lava or dust, we don't know. But most of the measurements have been made in a different position, with the instruments measuring some of the heat coming from this flattish area and some coming from the mountainous areas, like that. So it's obvious that the results can't refer to a particular kind of surface. They're very much averaged over these two types of surface, and we must therefore bear this in mind when we look at these models and realize that they don't refer to the whole surface of the moon. Now, I should expect to find on the surface of the moon a scene possibly like this. This has been drawn by the lunar artist L.F. Ball. And if we looked closer up at it, we might see something like this, a sort of pebbly surface overlaid possibly with a thin layer of dust. Other measurements, more detailed measurements made from the Earth, could of course shed a great deal more light on this problem, on the nature of the surface. But it seems before long that we shall have a rocket there, fully instrumented, making its own measurements close up on the surface. For instance, a rocket equipped with a television camera could photograph the surface close up, and we could have the results, the pictures, transmitted back to the Earth. If a small weight were ejected from the rocket and thrown to land on the surface, it would land and with that sort of result on a pebbly surface. But if the surface were dusty, of course, the weight would probably fall into the surface and produce some sort of splash like this. Well, if we wanted to know exactly what the surface materials were, we could analyze them by throwing out a sticky tape from the rocket and drawing the tape back so that possibly bits of the rock, bits of the dust would stick to it, and we could analyze these inside the rocket and send the results back. And of course, there are many more experiments which could be made like this.
Well, thank you very much, Dr. Fielder, and I'm quite sure you're right when you say that these experiments are going to be interesting, and I think they're going to be made pretty soon. I think you'll agree with that, too, because all the indications are that the Russians are now making such immense progress that almost anything may happen at any moment. And I, for one, am very anxious to see what it is. And of course, space travel itself lies in the future yet, but I think the first explorers may have some surprises when they first step out of their craft onto the barren, bleak moonscapes. Good night.